Does it work? You can check.
I did. It did work.
It should work now. Okay. We're just going to start this brief review session. If anybody has any questions, they can feel free to post on the chat. I'm just going to hook this up and see if it works. I think it works. Okay, we're good. Okay, so for the test, what you're gonna have to know, we're gonna go over just the important bits. You have to be very familiar with this diagram. So I want you to know the order of the electromagnetic spectrum, and which has higher wavelengths than the other, and which has higher frequencies than the other, and which has higher energies than the other, and the relation between wavelength, which is the opposite basically of frequency. So as wavelength increases, the frequency decreases, and frequency is basically the same or has similar trends to energy. So as frequency goes up, the energy goes up. So gamma rays have the highest frequency and highest energy, but the lowest wavelength. Similarly, in the visible spectrum, violet light has highest frequency, highest energy, lowest wavelength, whereas red light has the highest wavelength and lowest energy. And as we keep going down, radio waves and microwaves have super low frequencies, but really high wavelengths, the size of buildings, basically. So that's important. You have to know what kind of electromagnetic waves are there. And then the next thing is based on a diagram or description, or you have to provide the description between different sources of electromagnetic waves or light waves. In this case, this is mostly we just talked about visible light. We didn't really talk about sources of other electromagnetic radiation, but we know that it all has to do with movement of charged particles, right? So that's the important thing for an electromagnetic wave. Movement of electrons basically create electromagnetic waves, and we have to know more in detail about creating light or visible light. We have incandescence, which is light which is produced with a lot of infrared radiation, right? So this is basically, these lamps and bulbs are mostly creating heat or infrared radiation. They also create a little bit of visible light, usually in the reddish area of the spectrum. We have chemiluminescence, which is the light produced as a result of a chemical reaction, which include glow sticks over here. Bioluminescence, which is basically a chemical reaction in a living body, in a plant or animal specimen, which is bioluminescence. We have electric discharge tubes, which are an inert gas, usually noble gases like neon or krypton, and when you have a current pass through them, they produce visible light. We have fluorescence right here, and these are some images produced using a fluorescent microscope. So we have to know what fluorescence is. Fluorescence and phosphorescence, which is these two, basically involve absorbing UV light. So let's say this is the substance. It absorbs UV light and releases it out as visible light. So that's how fluorescence and phosphorescence work. The difference between fluorescence and phosphorescence is that fluorescence is instantaneous. So as soon as it absorbs the UV light, it releases the visible light, and that's very quick, and the visible light doesn't last for a long time. Phosphorescence, like these glow-in-the-dark stars, tend to last much longer, like halfway through the night, for example. They release visible light much more slowly and for a much longer time. The last thing were LEDs, where these are light-emitting diodes, which are basically made of semiconductors, and they're much more efficient than visible light and fluorescent light bulbs. So you have to know the differences, similarities between all these things and stuff like that. So that's going to be a major part of your test. The next major part of your test is law of reflection. So you'll have to state the law of reflection, almost definitely. Still haven't technically written the test yet. I'm just trying to think of stuff I put on right now. So I'm going to ask you to state the laws of reflection. So there's two parts, angle I equals angle R. And the second one is that the incident ray, the reflected ray, and the normal all lie on the same plane. So that's the two parts. You'll have to know what a periscope is and how it's used in a submarine. You have to know how to calculate angle of incidence and angle of reflection given a diagram like this. So those are important things. And of course, we have our main idea here. We have our drawing of image in a plane mirror and then doing salt with it. So I'm not going to go over too much of the details. I'll just quickly remind you. You have to pick the two extreme points. Mark an incident ray, draw your normal, find incident angle. Reflected angle is the same as incident angle, draw your reflected ray. The second incident ray can be with the normal, an angle of 0, so your reflected ray is also here. And you basically extend these backwards to find image at the point. If that was too fast, please watch the video where we go over this much more slowly. And then we're going to do the same thing basically over here. And then this should technically intersect somewhere here so that you get this as your image. So hypothetically, that's how it should work. So hopefully that was good with everybody. So this is definitely going to be one question. I'm probably going to give you to draw a triangle just because it's 3 points. And I'll give you like a straight arrow as well. So there'll be two drawing, or two or one. I'll probably give you the one triangle. I don't want you to draw too much. So there'll be one triangle question. Find an image of a plane mirror. Find an image of a triangle in a plane mirror. There's going to be a lot more questions with the ray diagrams. Most importantly, I forgot to mention this for the plane mirror as well, you have to salt all the images, so you have to provide a description. So I will give you maybe 3 or 4 of these, one convex, maybe more concave, where I'm giving you an arrow. You kind of have to draw your ray diagrams based on that, and there will be a define spherical aberration question, state what it is, and stuff like that. So you have to find the image of this arrow. It will always be an arrow that starts on the principal axis. You have to find the image of that point, and we know that convex mirrors always form virtual diminished images, and we know that concave mirrors, that really depends on where the image is formed. So here we have the image will be like diminished, it will be in between C and F, center of curvature will have the same size image at also the center of curvature. In between here you'll have a magnified image. At the focal point we know we have parallel rays of light, so no image is formed. And in between here we have a magnified virtual image. So this is the only virtual image formed by a concave mirror. You will have to know the relation between A and T, S and L. So we talked about that relation. If this is upright, it's virtual. If it's inverted, it's real. The size, if it's magnified, that means it's farther away from the image is farther away from the mirror. If it is diminished, then the image is closer to the mirror than the object. So we have to know those relations. And that's about it for your test. The last thing, there will be a couple of definition questions. Define angle of incidence, angle of reflection, center of curvature, focal length, vertex, and principal axis. So I'll give you like 2 of those and ask you to define them. But apart from that, that's basically all your test's going to be. So it's going to be mainly sources of electromagnetic radiation, the actual electromagnetic spectrum relation between frequency and wavelength, plane mirror images, laws of reflection, and curved mirrors, and these things. So how much of the test is on ray diagrams? That's a good question, Deepinder. I'm going to say most of the test is on ray diagrams. Like I'm saying, it's basically going to be curved mirror ray diagrams, plane mirror ray diagrams. The only thing that's not ray diagrams is the electromagnetic spectrum, sources of visible light, and definitions. I will be asking there'll be a little bit of the test which is like kind of, I'm going to say tricky multiple choice, or as tricky as I can make them, because I like giving you tricky multiple choice questions. It's fun. I also pulled this up. I will be asking you like some of these questions. These questions are important. And also in the review that I highlighted, can I pull that up? Let's see. November 5th, no, 15th, 14th. Look at these review questions, the review test in your textbook, and there will be one laser question. So let's say a shorter answer to your question is about 60% of the test will be ray diagrams. So you have to know how to draw ray diagrams, hopefully. If you don't, well, now's a good time to start watching them YouTube videos and practicing a little bit. Yeah, I forgot my textbook at school, so I basically don't know what these questions are, so I'm going to randomly pick maybe 1 or 2 of these questions and throw them on the test. The test I envision to be 60 minutes long, so based on my rule, it'll be out of like 45 marks, or out of 45? Out of 30 marks is 45 minutes. Yeah, roughly out of 45 marks. Your test will be out of, and I'll give you about 60 minutes to do it. What happens when you shine incident light along the normal? Good question. The answer to that question, where's a blank page where I can write on? Okay. When you shine, so let's assume that this is the surface of a plane mirror. When you shine incident light along the normal, the angle of incidence is 0, so angle of reflection will also be 0 according to the law of reflection. So your reflected ray will bounce right back. So that's what happens when you shine it. It just shines right back. Good question. There'll be a laser question. I said that already. Yeah, and I'll just pick, like I said, I left my textbook in school. So I'm going to pick 2 random questions from this review and throw them on. Oh, lateral inversion. I just saw that. Probably going to ask you to define lateral inversion. Oh, and I have to ask you about specular and diffuse. See, now there's too many things to put on this test. I'm just going to not ask you some of these things. So there are going to be a lot of ray diagrams, but there's also going to be like 2 questions from here, lasers, definitions, specular and diffuse. It's not, the actual test is probably not going to be too hard, I think. Hopefully. Yeah, so I pretty much just answered that. I'm going to say like a little bit of the test is going to be hard, just so that you know everybody doesn't get 100%, because I don't like that. For some reason. I don't mind everybody, actually, when I think. Okay. There are going to be like some questions that are kind of difficult that will make you think. Otherwise, the test is going to be questions basically that you've seen before. So there's no like tricks or things for most of the test. What is special about a laser? That's a good question. A laser, so normally, where's my blank page again? Where did I go? Okay. Normally any light source has a lot of different wavelengths of light that are coming out from it. So it's not, even if you have like a purely red light bulb, you're going to have a lot of different wavelengths of light. So it's going to be a range. So if I look at like a blue light bulb, it'll have wavelengths from about, let's be very specific here, it's going to have wavelengths from 500 to about, 475 to 500 nanometers is going to be the wavelength of the blue light from a blue light bulb. But a laser has only one wavelength of light, so that's what's special about a laser. So lasers, just one wavelength of light. So for example, that could be like 475 nanometer lasers. So you can buy a laser that has this exact color of blue light, it will be roughly. If you want a red light laser, that would be approximately 700 nanometers, but it has only that exact wavelength. The second thing that's important about a laser is that it has intense light. So it's a very intense beam, it's a focused beam, so it travels a lot longer distances than normal light. So you can, if for example you can shine a laser at the moon and it will bounce back, and you can measure the distance that it traveled, etc. So that's what's special about a laser. Will you give us, okay, so I am going to go over ray diagrams again, Mr. MacDog, or Miss MacDog, I don't know. Will you ask questions where you give us a scenario that asks us to use ray diagrams in order to solve it? Interesting question. Now that I'm thinking about it, that's actually a pretty good question to ask. But, since you suggested to me, I will not ask you those kinds of questions. So that's a no. I will save it for the actual unit test, or I'll put one of those questions on the exam, because now that I'm thinking about it, that's a super cool question. But for tomorrow's test, no. It'll just be like, find the image of this arrow, or find the image of this triangle, and that's it. That's all that's going to be on your test. I like pickles too. That's not really related, but based on comments. Okay, ray diagrams. Which ray diagrams? Do you want me to go over all ray diagrams, or like plane mirror ray diagrams, or like concave or convex mirror plane ray diagrams? Can you be a bit more specific there? Because all the ray diagrams will take a really long time. So, yeah. Also, not that you really have to know this, there is a bit of a lag between what I'm saying and you're actually hearing it. I think it's about 20 seconds, that just because, for the electromagnetic waves to travel all the way up to space and then back down, or however this is happening. So What's an example of a tricky question? An example of a tricky question is something like, where's my... I would say this is an example of a tricky question if I do not give you the diagram. So I will just give you this sentence, and you have to tell me that the angle of reflection is 60 degrees without the diagram. So you have to kind of read the question and say, okay, angle of 30 degrees with the mirror surface. This means that the angle of incidence would be 60 degrees, and so the angle of reflection is also 60 degrees. I can also ask you like questions like, what happens if I decrease the angle of incidence? What will happen to the angle of reflection? It will also decrease, that kind of thing. But I'll try and word it so that it's tricky. So that's basically what the trickiness is going to be. It's just going to be you trying to understand the question before you actually have to solve it. How many questions are there on the test? How many multiple choice? How many long answers? That's a good question. I still haven't made the test, so I'm not entirely sure. But I'm going to say there's going to be at least 3 or 4 ray diagrams, 2 or 3 multiple choice questions, 4 or 5 multiple choice questions, and there's going to be like a couple of short answer questions. By a couple, I mean around like 5 or 6. So that's the closest breakdown I can give you right now. Yeah, that seems about right. 5 or 6 short answer questions, same number of multiple choice, and like 3 or 4 ray diagrams. 1 plane mirror, and then the rest will be curved mirrors, concave or convex. Hopefully that answers your questions. Okay, convex mirrors. Let's go to a convex mirror. Oh, I am on curved mirrors. Okay, so for a convex mirror, let's start with an arrow over here. And so the first rule is we're going to draw a ray that is parallel to the principal axis, appears to diverge from the focus. So we know a convex mirror is a diverging mirror. The convex is curved outwards, so this is diverging. So it's going to bounce away from the focus. So we don't technically need to draw this before, we just know that it's going to emerge that way. And then the second rule, we can say we aim it at the focus. So I'm going to sort of try and aim this as best I can without a ruler. And that's going to emerge parallel to the principal axis. So that's our second rule. And then we extend this 2 backwards because the image is formed where 2 rays meet, and so therefore that is the image location. So basically you just have to use these 2 rules for all the curved mirror ray diagrams. It's actually not that bad if you like really think about it. That would, okay, that's cool, MacDog, Mr. MacDog, Mrs. MacDog. I have no idea who MacDog is. I honestly, this is interesting because just when I come into class tomorrow, I'm going to look at everybody and be like, are you MacDog? Are you MacDog? So that's going to be me tomorrow in class. So that's going to be fun. It'd be interesting to guess who MacDog is. Well, we should just play guess who MacDog is, I think. Maybe that should be a question on the test. Maybe that's a bonus question. I'll be like, take your best guess of who MacDog is. That way, MacDog can get the bonus answer correct because, he's MacDog or she's MacDog. And the rest of you can take your best guess, and I want to see who that is. Please don't make the test too hard. Okay, like I said, the test's not going to be hard. Ray diagrams, if you know that, if you know sources of light, if you know which EM waves have high frequency, low frequency, and you know definitions, you're going to be fairly covered on your test. So that's going to be that's going to be most of your test. The only difficult questions, the tricky ones, will probably be maybe 2 or 3 multiple choice questions. Yes. We'll be asked to label. I will not ask you to label wavelengths. So you don't have to know the wavelengths of anything. Visible light would be nice. It's good if you know that, for future. I just think it's a good thing to know, 400 nanometers to 700 nanometers, especially if you are taking science and stuff. But I will not ask that question on the test. So you do not have to label wavelengths. So is that a confession, Mr. MacDog? Well, now, Miss MacDog, are you identifying yourself, which ruins all the fun that we were gonna have? That's a good question, MacDog. Have you been listening? You will not be asked to label wavelengths. I will in terms of wavelengths. What I'm gonna ask is, how many, what are the electromagnetic spectrums with the lowest wavelengths, or which has a higher wavelength, that kind of thing. I won't ask you to label, state any values for the wavelength. I'll just ask you which one has a higher one, or which one has a longer wavelength, which one has higher energy, which one has higher frequency, and that kind of thing. Do we have to label the EM spectrum? Label the EM spectrum. I'm going to say no. You are Rachel. See, MacDog, but do I really know that you're Rachel? Maybe you're just throwing Rachel under the bus. I don't know. How are we to know that you are Rachel? It's okay. It doesn't matter if you're Rachel. Okay. The point is, getting back to the actual question. I'm sorry, Noor. No, you will not be asked to label the electromagnetic spectrum. I will ask you, I'm giving away a potential question here, but I will ask you which ones are visible and which ones invisible. So, obviously, it's, again, everything except the visible part of the electromagnetic spectrum is invisible. So, that's kind of easy. But, no, I'm not going to ask you to label it per se. Math problem regarding the rules? No, because we covered that only on Friday, and I'm not going to put that on the test. It's also not on the review, so there will be no math problems for this test. There will be a lot of math problems for next test, so there you go. Interesting. Yes, Bill, I'm sure you are just trying to learn. Yes, what is your question? See, again, you can never know. Okay, if anybody else other than Bill and Mac have any questions, you can ask. Otherwise, I'm just gonna have you seen the new Dr. Stone episode? I have seen the new Dr. Stone episode. They make a water wheel, which is pretty cool, and that guy came up with it on his own. So yeah, that's pretty lit. Yeah, it's just crazy how he has I was talking to my friend, and he has this. very precise knowledge of like so many things, and it's crazy. Disney Plus is insane. See, is it okay? So is Disney Plus worth it, MacDog? Do you know where the owl guy went? Who's the owl guy? Yes, I guess I got off topic here. But again, if you have any questions, feel free to ask. Good bonus question, though. I wonder if I could like ban MacDog for being too immature. I gotta figure out how to do that. But well, that's for next chat. Otherwise, if anybody doesn't have any other questions, I'm gonna sign off, and I will see you all tomorrow, where we're gonna write the test. So again, I have to discuss. Will there be any bonus questions? There be any bonus questions? I will include some time pass questions. So like if you finish the test early and you're like bored, I will include like some questions at the back which you can just do for fun. I will think about making those bonus questions. Some teachers have rules against bonus questions. I don't know if Miss McKenzie likes bonus questions or not, so I'm not sure yet. But there will be some fun questions to do at the back. Make the test Tuesday, please. I cannot make the test Tuesday, I'm afraid. I'm sorry. That is not possible. The test is tomorrow, guys. That's why we're doing the review right now. I told you what you have to study. You just have to study. Like, you can literally like get an 80% on this test if you start studying now. You just have to know relationship between frequency and wavelength, ray diagrams, and that's it. Will we have to know the uses for laser lights? No, you just have to know what's special about a laser light. That's it. No uses. I'm so like... I'm so confused by this chat, but that's okay. Will the questions for fun at the back be marked? They will be marked. Again, I'll mark, like you can try them if you want. I'll mark them. I don't want to call them a bonus question. Let's put it this way. If you do all those questions really well, I may forgive some mistakes that you do on the actual test. So it's not like a bonus question, but I'll be like, lenient. I'll be more lenient if you get those questions right. Does that make sense? Yeah, sort of. Or I don't know. I'm gonna ask Miss McKenzie if I can just give you like 2 marks for a bonus question, and then I'll just give you the bonus question. Oh, and I also should mention. I probably just mentioned right here. If anybody skips the test tomorrow or is absent for a unexplained reason, I will make the retest super hard. Yeah, that's what I'm gonna do. You're gonna have to see again, because of the lag, I don't actually know what you want me to repeat. But MacDog, you know what? You could be the bonus question. I'm just gonna ask everybody to guess who MacDog is. You're so scared. Okay, don't be scared. This is like, you're supposed to be excited instead. This is like a way to, I'm not, like, I can't, you can just rewatch the whole video. You don't have to go over it again. I don't have to do it all over again. Yeah, you just like, scroll back. See this red thing? I can't show you. Okay, I can actually show you the red thing. Wait, I don't know. This might be a bit trippy, but you see this red thing right here? You scroll back, and then you watch the entire video again. Okay, guys, like I said, you should be excited and not scared. This is like, what is it? It's just like a fun thing, fun activity that we're going to do tomorrow. There's no learning, you're just like writing stuff. It's super cool. What is the 43rd element on the periodic table? Excited to fail. No, not excited. You guys will do fine. Don't worry. Again, if you know how to draw ray diagrams and if you know the sources of light, you're pretty much passing right there. So that's that. Don't flip a desk, please. That's gonna make me do some paperwork. I think I don't want to do paperwork. Bonus questions, like I said, I'm just gonna, I like to put questions at the back, so if people finish the test early, they can just work on those questions, so they're not like sitting bored out of their minds. And if you do those will probably be like the math questions or like scientific notation or unit conversions, I'm thinking. So if you do those questions correctly, I might go lenient on you if you make like a small mistake here and there. I won't take off like half marks, basically. How many marks would a definition be out of? It would be out of one question, 1 mark. You're stressed about the questions on the back. Those are literally not going to be marked. They don't affect your mark in any way, much. They don't affect, if you do everything in the front right, there's nothing the questions on the back are going to be used for. You give me $20 to make the test on Tuesday. I'll pass. $20 ain't going to cut it. So, sorry guys. I'm a bit more expensive than that, you see. I'm not going to say it. What is the relationship between wavelength, frequency, speed, and energy of an EM wave? That's a good question. So speed is always constant. So electromagnetic waves have the same speed in vacuum. That's 3 times 10 to the power of 8 meters per second. Wavelength is, like we said, the distance between 2 crests or 2 troughs on a wave. And basically, radio waves have the highest or longest wavelength, and gamma rays have the smallest wavelength. Frequency is what is called the inverse of wavelength, so it's the opposite of wavelength. If wavelength gets bigger, the frequency gets smaller. And if you remember that circle we did, where the size of the circle represents our wavelengths, and yeah, I'm sorry about the echo. My mic is acting up. Whoops. Interesting. I actually don't know how to fix this. It happened like the last time I tried this too. I think you maybe can try refreshing your page, or because it still says my connection's good. Interesting. Let me try. I'm going to continue. The echo, as I'm told, is not super bad. So if you're like, okay. We did the wavelength. The bigger the circle, the longer it took to pass around, so the lower the frequency. So here radio waves have the lowest frequency and gamma rays have the highest frequency. Energy is the same as frequency. So energy is basically related to frequency directly. So if you have a high frequency, you have a high energy. Low frequency, low energy. And this kind of, this thing? This kind of shows it. So radio waves have long wavelength and a low frequency. gamma rays over here have a low wavelength, like 10 raised to negative 12 is your wavelength, and they have a high frequency, so 10 to the power 20 hertz. Oops. That's the frequency. It's pretty bad. That's my bad. Okay, I need to also do sources of light. I talked about this a bit before, but we have incandescence, chemiluminescence, bioluminescence, electric discharge, fluorescence, phosphorescence, and LEDs. Those are the sources of light. I guess technically there's the triboluminescence, but I hate that, so that's not going to be on it. Can you define high and low? Well, that depends. I'm going to be asking you relatively, so maybe I'll give you a question like, which has a higher wavelength, radio waves or X-rays, and you have to tell me which one has a higher wavelength. So I won't be asking you like the value of high or low. No, I'm not going to guess what, MacDog. Just calm down. But the values of high and low are given on here, basically. So for a wavelength, a high wavelength would be about 1,000 meters. A low wavelength would be 1 picometer. Frequency, a low frequency would be 1,000 hertz, which is kind of the high part of the wavelength. And a high frequency would be, see, this is why I didn't want to guess. A high frequency would be about 10 to the power of 20 hertz. So that's a big wavelength. Big frequency, sorry. Yes, I'm sorry for my language. When I mean higher wavelength, I mean longer, because wavelength is a distance. So, oh yeah, I'm gonna stay up all night and make this test. So that's usually what I do. And I seem good at I'm actually horrible at games. The only game, well, actually, I'm pretty bad at like FPS games. So Fortnite's not my forte. I play Mario Kart. So if you're, down to like race sometime, that's cool. But no, okay. What every test you're gonna ask me like. Even if I do put the test on Tuesday, this is gonna be the same issue. Like tomorrow night, you're gonna be like, "Oh, let's make the test on Wednesday." Just write the test tomorrow, and you'll be fine. I'm a Game of Thrones book guy, so it's actually called, Song of Fire and Ice. Game of Thrones is just the first book. I'm reading the books currently. They're pretty good. I've got as far as who plays Okay, Mario Kart is like a cool game. I think. I'm pretty sure it's cool. Still. Hopefully. But, yeah, I forgot I lost my, oh yeah, Game of Thrones. Okay, does anybody have any, like, science questions? Also, we will be, so tomorrow's class, for the first 15 minutes, we're going to be talking about, like, some, like, things that I may have, like, oversimplified on my answer key. So I'm going to ask me a question. If the sun gets hotter, technically it will look blue. This is my cat. Say hi. Cat. Go away, cat. It will look blue, and I made a mistake on the answer key. And we'll be talking about why that is. For first, like, 10 minutes tomorrow, I'll give out the test, and then you can do the test. Okay, it shouldn't take you longer than 45 minutes to do this test, but I'll give you like 60 minutes because I'm nice. MacDog's calling you all kids when he's like the same age, or she's the same age. Again, I still can't figure out who MacDog is. This is crazy. It's going to drive me crazy tomorrow. Like I said, I'm going to be looking around the classroom, be like, are you MacDog? Are you MacDog? If blue is the hardest star, how come... See, okay, that is an excellent question, Mr./Miss Dill Pickle. And that's what we're going to be talking about tomorrow. There's a couple of factors that influence... You are not going to need 61 minutes. There's a couple of factors influence that, like, caused Herschel to find red as the hottest color. And that's what we're going to talk about. So it has to do with why the sky is blue. And you don't get 61 minutes. I agree with you, MacDog. I agree with you again, MacDog. MacDog is distracting. Okay, MacDog, can you please stop distracting people? That doesn't help. Okay. I forget what I was saying. It has to do with... Okay, cat, just shoot. Interesting. I'm going to see... if I can... No, can I... Okay. Again, if anybody has any science questions, you can ask. You like my room? This is... Oh, thank you. Again, MacDog. MacDog, have you asked me like a single science question so far? I feel like no. You've just been like randomly. No, you're like clear. Okay. Mr. MacDog. Can you guess? See, that's what I'm trying to do, but I can't. I literally don't know. It's impossible to tell. But yes, if anybody has any other questions, except from science-related questions, except for MacDog, they can ask. Do you know when we're getting our report cards? This week, actually, so very soon. Can I block MacDog next time? I'm going to figure that out. I can... Maybe I could. I'm sorry, MacDog. Luckily you're anonymous, so you could just kind of change your name and come back, I guess. But I'm just kidding. I won't actually block you. Don't worry. I don't think I can anyway, but that's not the point. The disrespect. Funny. Who would MacDog? Okay, let me think. Let's see. Okay, so it's definitely not Rachel. So I'm going to go ahead and guess. I don't know whether me guessing is a good thing or not. I'm not going to guess out loud, but I'm going to guess in my head. Okay. I see that there's like, apart from MacDog and Jason, there's like 15 or 14 other people here. You don't all have to be here. So again, I'm going to wait for exactly 2 more minutes, and if there's no science-related questions, I will log off. Let me see. Well, this is interesting because even if the chat... Okay, never mind. Alright, is everybody good? Don't worry, test's going to be super easy. No difficult questions except for like 2. And yeah, that's it. Yes, that's totally plausible. Who is MacDog? Maybe I might. It depends on how I'm feeling. But like, what if Miss Mackenzie looks at that and be like, "What is this question?" I don't know what to say. So. And like, okay, technically all the people from class are not here, so like half the class is just gonna look at that question and not understand anything at all. So I don't want to like confuse half the class, you know. So unfortunately, I cannot ask that question. I'm sorry, Mr. MacDog, Miss MacDog. Okay, I have not seen any science questions for 3 minutes, so good luck on the test. You'll be fine. Again, just do ray diagrams and stuff like that, and you'll be good. Alright? Oh, sorry about that. That's my roommate. I think he's watching anime. So yeah, that's what's going on there. Yes, me too, except I also have to write a test. How does light behave differently when it's in a vacuum? It does not behave any differently in a vacuum. It can just travel in a vacuum. Just as... But other waves cannot, like, ocean waves and stuff. My cat is trying to claw me. Ouch. How does light fool us? Technically, light does not fool us. It's just the... that's just... I want to ask you that question, per se. It's just to make you understand that we believe that light always travels in straight lines, even though it might not be actually traveling in straight lines. So even like after light starts, even after light is reflected off a mirror, for example, we draw dotted lines because we believe light travels in straight lines. Please make the test easy. I will think about it. Can you repeat the main things that are going to be on the test? Okay, one last time. There's going to be sources of visible light, so chemiluminescence and all that stuff. There's going to be relation between frequency, wavelength, energy, and relation to the electromagnetic spectrum. There's going to be definitions of, lateral inversion, and I just said lateral inversion and stuff, but focal length, center of curvature, incident ray, reflected ray, vertex, principal axis, those definitions. There's also going to be ray diagrams, which is basically most of the test. Curved mirror ray diagrams, plane mirror ray diagrams, and there's going to be like a uses of curved mirror. So like where a curved mirror, where's a convex mirror used, where a concave mirror used, that kind of thing. Yes, you will need a protractor for the class. Lateral inversion, the definition of lateral inversion is the switch from left to right when something is viewed in a plane mirror, is lateral inversion. Why do people living in hotter areas have darker skin? People living in darker areas, hotter areas have darker skin. This is because of the sun's UV rays. So where there's a lot of UV rays, we need to produce more melanin in our skin to protect us against against the harmful UV rays. So places where there's a lot of UV exposure people will evolve basically to have a darker skin, which is more melanin production. But we also need some UV rays available to produce vitamin D, which is important. So people living in places where there's not much UV light have very light skin so that they can absorb all the UV that they can get. Where are convex and concave mirrors used? Read the textbook. Convex mirrors are basically used in car mirrors because you can see a diminished image. Concave mirrors are used, so like we talked about how searchlights and flashlights use concave mirrors where they're at the focal point so that you get parallel rays of light and stuff. Okay, first of all, don't stay up all night studying. The test is not going to be hard. Convex is shoplifting, actually. I'm pretty sure. Let me check that. Is there going to be short or long answer? There's not going to be any long answer questions, except for like ray diagrams. Short answer questions, there's going to be a bunch of them. Well, just like all the kinds of questions like the wavelength, sources of light, definitions, those are the kind of short answer questions that I'm thinking of. Interesting. Do we need to memorize the sources of light? What does that mean? Okay, MacDog, have a good night. Don't let the bedbugs bite. I will see you tomorrow. Maybe. Do we need to memorize the sources of light? I'm going to say no. Sort of. What is a periscope? A periscope is the little device that is used in like a submarine to see outside. So it uses like the two mirrors at 45-degree angles. That's on November 6th. Like this. This is a periscope. So light, but it's like tilted. I can't tilt this, but it's tilted this way, so the light coming in from like outside the submarine basically will bounce, and then you can see what's inside the submarine. That is not what a periscope is. MacDog, go to sleep, MacDog. Good night. So you're okay. Good to know. Technically, MacDog, I have to report that because underage drinking is not allowed. So I'm going to take a screenshot of this conversation and then report you to the authorities. The only problem is I still don't know who you are. Silly goose. Interesting. Okay, like I said, the rest of you who are actually... Do we need calculators? No. Protractors? Yes. The rest of... Okay, anybody who's not MacDog, who's like, doesn't have any science questions, can log off. Again, this is supposed to be like 20 minutes. I've been here for an hour, so... I'm gonna sign off about now. I'm gonna say. I'll give you like one more minute. If you do not have a protractor, one will be provided to you. But try and if you don't own one, that's fine, I'll give you one. But if you do own one, try and bring it so that we don't run out. Message. Do you want there to be a question on periscopes on the test? I can put it in there if you like. But I'm going to say probably not. There's not going to be a question on periscopes. And I was saying probably, that's probably not helping really, but do I want to put... No, there's not going to be a question on periscopes. How is light considered energy? How is light considered energy? That's a good question. Light is basically a kind of energy. But it's also... Okay, wait, what am I trying to say here? I'm confused by, like, what do you mean, how is light considered it? Light is basically energy. Okay, MacDog, go to sleep. Everybody else, don't be stressed. The frequency times wavelength questions will be probably like bonus questions that I'll put at the end, which won't be for marks, like I said, so you will not have to do those kinds of questions. You do not have to memorize EM waves. You do have to remember what order they come in, but you do not have to memorize what the frequency or wavelength of those things are. But you do have to know that gamma rays have highest frequency and radio waves have lowest frequency, and X-rays have a higher frequency than radio waves and that kind of thing. How can we not be stressed? I don't. Okay, it's like you guys are in like grade 10. You should like chill more and not be stressed. Like, I don't know. Like, it's fine. Like, even if you don't do well on this test, do well on the next test. And, stuff like that. Basically. Okay, again, this is not the full unit test, right? This is like the mini unit test. We're not really done the unit yet. Is my phone out of battery? What is color? Color is just different wavelengths of light. So it's not, color is what we perceive when our eyes kind of interact with different wavelengths of light. So it's just a part of the electromagnetic spectrum. No, there are not going to be any long answer questions related to EM waves. Okay, I'm just looking at my phone right now because hopefully we are done. Anybody have any other questions? I'm going to say that's a no. If you do, then don't worry about it. It will be fine, basically. So I will see you guys, girls, in class tomorrow. All right. Good night.